Hello and welcome to this Astranti YouTube video on limiting factors. This is one of many videos that we're going to be publishing on YouTube. We've got videos relating to topics, videos relating to the objective test exams, and also the case study exams as well, and various different videos about technique. And if you do like this video, then please like and subscribe at the bottom of the screen, or visit the Astranti website, www.astranti.com, for more information and more samples. But in this video, we're going to look at limiting factors. And it's a very important topic, particularly for your BA2 and your P1 exams. What limiting factors relates to is some factor that limits production within a particular period. So something that's going to stop you from producing as many products as you would like within a particular period. Now, this could be due to the fact that you have limited machine time and your machines can only produce so much. Or if you have manual production, you have limited labor hours and your staff can only produce so much. Or that the material itself is just limited and you haven't got enough raw materials to produce enough products. So, how would this work in action? We understand what we mean by a limiting factor. We understand what kinds of things may be limited, but let's see how it plays out and how we calculate it, how we make the most out of the resources that we have available. As that's one of the key concepts within limiting factor analysis, is looking at how you make the most out of your limited resource. So, we have a company here, and this company makes 3 products. They make product A, B, and C, and A, B, and C are made using materials X and Y. So let's bring up some information relating to these various different products. We've got A, B, and C, and we've got the quantity of X and Y required for each one. You can see that product A only requires 1 ton of X, but it requires 6 tons of Y. We also have different sales demands and different contribution per unit. The contribution, of course, being the contribution that each sale makes towards paying off fixed costs. So it's calculated by taking the sales price and deducting the variable cost per unit. And very important figure within marginal costing and also in limiting factors. And we actually have limited material. So our machine time and our labor hours is all right, but we have limited material. We only have 2,000 tons of X and 2,000 tons of Y. So that's going to be our limiting factor. And we need to know which products we should produce first to get the most contribution from the available production that we can make. So first step is to check the sufficiency of X and Y. We have 2,000 tons of each. Is that going to be enough to produce all that we can of products A, B, and C to meet our maximum sales demand? So we bring the sales demand down into step 1. We can sell 150 for product A, 100 for product B, and 200 for product C. And the material X required is as follows: 1 ton for product A, 2 and 3 for B and C respectively. So the total amount of material X we use in production if we were going to produce as many products as we can for each of our 3 products is as follows. We take our 150 in sales demand and multiply it by the material per unit, giving us 150 tons of X used in product A, 200 in product B, and 600 in product C, giving us a total tonnage usage of material X of 950 tons. So we're well within our 2,000 ton limit. But what about material Y? It uses a lot more, 6 tons for A, 4 tons for C. So we repeat the process, multiplying the material required per unit by the maximum sales demand. So for product A, that's 900 tons. For product B, 500 tons. For product C, 800 tons, giving us 2,200 tons of material Y required. So this is the limiting factor, because if we wanted to produce our maximum amount for products A, B, and C, we do not have enough of material Y. We only have 2,000 tons available. So 2,000 tons is not sufficient for Y. It is sufficient for X, but it's not sufficient for Y. So we know that we are not going to be able to produce our maximum amount for A, B, and C. We just don't have enough of material Y available. So we now have to decide which products we are going to produce. And we need to choose which one has the best contribution per ton. So it makes the most efficient use of the resource that is available. And to do that, we first need to calculate the contribution per ton for each product. And we've got the contribution per unit here, £75 for product A, 100 for B, and 60 for C. And we've got the quantity of material Y required for each. And so to find the contribution per ton, we take the contribution per unit and divide it by the tons needed. So for product A, that is 12.5 pounds of contribution per ton, or £12.50 contribution per ton. For B, that's £20 contribution per ton, and for C, £15 contribution per ton. So when we rank the products in accordance with the contribution per ton, we produce as much of product B as we can, then all the product C's that we can, and then finally product A's with what is left over. So then we move on to step number 3, which is to allocate material Y. And we looked at our different products, starting with product B, as we know we're going to produce product B first. And we have 2,000 tons available. That's the most that we have available. And we're looking to produce all the product Bs that we can. And we've got 100 units, as that is our maximum sales demand. And we know that the total amount of material Y used to create 100 units of product B is 500. So we're going to use 500 tons of material Y. We started with 2,000. We've now used 500. So we have 1,500 tons left over. We produce as many product Bs as we can because it has the highest contribution per ton. So we move on to product C. We've got 1,500 tons of material Y available now because we have already used 500. And we're going to try and produce product C's, and we're going to produce as many as we can before we produce any product A's. So we're going to produce 200, and 200 units of product C has a material Y usage of 800 tons. So when we use the full 800, we deduct that from the 1,500, we now have 700 tons available. And whatever is left over, we just produce as many product A's as we can. We can't just produce more product B's because, of course, the demand is only 100 units. So we have 700 tons available. And so we produce 116. We know that the maximum sales demand is actually 150, but that is the amount of product A's we can produce with the 700 tons left over, given that it uses 6 tons of material Y per unit. And that uses the full 700 and leaves us only 4 remaining. And of course, we can't actually produce any more with that 4 ton that is left, because we can't produce any more product A's because it requires 6 tons, and that 4 tons that's left over is not enough to produce any more B's or C's, or even if it can produce another C, there isn't the demand for another C. So in total, we have used 1,996 tons of material Y, and we have essentially produced the best possible mix of products to maximize the contribution to the organization in the short term. And that's how we have maximized the contribution, maximize the return to the company when there is a factor that limits production within a period. And that's a very useful method to learn, particularly for your BA2 and your P1 exams. It's a very important topic. So thank you very much for watching this video. I hope you have enjoyed it and found it useful. If you do want to see more of these, then do please like and subscribe at the bottom of the screen and visit the website www.astranti.com. So thank you for watching and goodbye for now.